So today we'll start learning on code smell, refactoring, and technical debt. So all these three terms are very much interrelated for the software maintenance. So from our previous discussion, we already know that. So these are the indicators of software decay. So software decay sometimes is called system decay or software rot. In software engineering, when we have gradual deterioration or gradually our system become worse over time, maybe for it has reduced performance or increased complexity and decreased maintainability, we usually say this is system decay. So these are the main reasons. So we have learned this from our previous discussions. Still, I can say one or two terms. So running an emulation mode means whenever we don't have any real system, rather we pretend that we are running on a real system. For example, if we have a game, it runs maybe old DOS system, so we can use any DOS related emulator. So it will serve our purposes, but it will definitely not produce the performance that we expect. So there are some other reasons, maybe can say the overly complex structure. So it has there are many reasons. For example, if we have complicated architectures, or if we add irrelevant features, or the code is written poorly, for this reason our system might decay or reduce its performance. So you can just check the previous slides for the main indicator of system decay. So how we can improve when a system actually gets decayed or reduce its performance? So that technically the system can be improved during maintenance. Especially we usually do not follow the preventive maintenance. So we know that preventive maintenance means, say, modification of a system product, maybe after delivery, and we can anticipate that there might be some faults in future if we work in advance about those features. So this is called actually preventive maintenance. One example could be maybe database optimizations. So when we have a database schema, very first we have a very small amount of data set. During operation, we update, delete, or insert many data. So there might be some issues for optimization of the database indexes. So rebuilding the indexes could be one preventive maintenance task. There are some other concept that we have our plan today's lecture, that are code smell, code refactoring, and technical debt. Maybe we'll check one by one. Technical debt actually definition the cost associated with a compromised software system that became difficult to maintain or improve. The debt within the system becomes a constant anchor or obstacle on software productivity, and it can impede or hinder our the ability to efficiently or new features. And delayed technical work that is incurred or experienced when technical shortcuts. So this is the main reason. Say we have a deadline, we have uh, to meet the deadlines. We need to submit it very early. So in those situations, what I do, we follow the shortcuts so that we can meet the deadlines. But majority of the cases, we do not follow the ideal path and optimized path. But when we later improve or deploy the system, we need to pay off the shortcut that we have followed in the previous step. So this is kind of type of debt. Since, for example, we have financial, if we consider the financial debt, the financial debt is contain kind of the expense that we need to bear. So this is analogous, or this is identical thing with the technical debt. So whenever we do something in our development stage, but we need to pay it off later stage of the maintenance. So there are some symptoms of technical debt. For example, poor customer responsiveness. When we actually unable to quickly address the customer feedback, and this is kind of our poor responsiveness. So we need to anticipate, we need to assume that there might have some technical debt. That's why we cannot respond the due time. So it might have many reasons from the management side also. So might be inefficient process or lack of prioritization, lack of transparency. So these are the main reason when management and customer are actually dissatisfied or lost their faith during business. So another reason, another symptom could be long-term, long delivery times. So when we extend periods for deliver the new features or update, so it can actually frustrate the customers. And the root cause could be the main reason, the technical debt, or maybe poor planning or lack of automations. Late delivery is also when we actually fail to meet or the promised deadline. So this is could be one symptom of technical debt. So it definitely harm the credibility of the customer trust. So root cause could be maybe poor code quality and unrealistic deadlines, or these are the main things. Another reason could be lots of defects. Major portion of the development capacity goes to defect fixing. addressing the issues. Rising development cost. So it could be the reason that we experience the technical debt. So per hour man cost actually increase, or the developers has higher cost. That could be one reason of the. So it could be a reason that unrealistic lack of say recognition or poor work-life balances. This could be the main reason. The last two steps could be, they are very much interrelated: rising development costs and frustrated poor developer teams. One is proportionally connected with the other things. So these are the main symptoms that we have technical debt. So this is one visualization that it was a visualization from in the year of 2020. And the trend showing that percentage of unplanned work over the past year. So on average, 40 to 50% development time is wasted on unplanned work. So we have for each bar, we can see one is darker, one is light. So if we see that the unplanned work is kind of in the fade one and the lighter one, so we can easily see that. So unplanned work, definitely we have a budget, or we have a plan of commitment when we submit our project. So this visualization give us insight that how actually the technical debt or codes may actually affect our total planning. So there are some metrics, or there are some quantitative techniques how we measure the technical debts. The first one is the amount of duplicate code. So it quantify this metric actually quantify how, to what extent, or how much of our code is repeated across the source code. So if we have duplicate code, we might be feel inconsistent when it is operational our software. For example, if we measure one shape, for example, area, in any part of our source code, so measure area. So in another place, we are measuring maybe area of rectangle. So one is area of square, maybe another one is area of rectangle. So it does not actually consistent. What we can do, we can just wrap up the total related features, and we can combine them in a single position, so that our system do not get confused and we do not experience the inconsistent state. So another one is rules compliance. So rules compliance actually, to what extent, how we actually adhere or carrying out the standard coding style, guidelines, and practices. So if we follow non-compliance or non-standard coding techniques, that might be leads to our inconsistency in the operational phase. Even this code could be error prone because in the total life cycle of the system, there might be different developers, and they may debug, or they may later extend the features. So if we have non-compliance coding style, we might be fall in real trouble. So we have we have two different types of comments. One is interfaces, another is in general cases. So what comments actually does? So if we consider that we have some APIs, or we have some abstract class, we just show the signature of the classes or the methods. So how many parameters are there and what are the tasks of those parameters? If we do not give the proper comments on those interfaces, so there might be some parameter assertion that lead wrong output, and it will produce some technical difficulty later part of the system. So another is general comments. So for example, if we say about a declaration thing or any methods, so what are the major tasks or major parameters, or what are the definition of those parameters? We must need to give the comments. Without giving this thing, we actually we can measure what are the technical depth. So these are actually metrics by which we can measure our system has how much technical depth in future. So another one is package interdependencies. So sometimes we use different libraries. So these libraries is highly interdependent. So if we will have, if we increase the interdependencies, so it is difficult to modify, or if we to test those code. So it's wise, we need to make some source code base, so that we can reduce the library interdependencies. Method and class complexity. So we evaluate in this technical metric is a technical dev metric, the complexity of the methods or classes. So we have learned how can we measure the complexity. So if you remember that we have used a cyclomatic complexity. For example, in a source code or in a class, we have a starting point. We can to reach to our solutions, we might experience several paths. So deciding those paths actually is done by the cyclomatic complexity. So one method or class would be, if it is very complex, it's definitely one indication of that we might have technical depth, because during maintenance we may need to modify this thing, but since it's complex, so this is important technical debt. Automated test coverage. So we can measure the portion of the code actually covered by the automated test, say unit test, integration test, or regression test. Manual test coverage. Sometimes we also need the manual test coverage because definitely we need to make it automated first. But in some situations, automated test coverage is not possible. So we may need to conduct manual testing. So manual testing those time consuming. So the last one, what we are telling, whenever our system or it has automated test coverage, we will say that we have less technical debt. But sometimes we keep our manual testing coverage, but we'll try to make it less. So these are the process causing technical debt. So it indicates that, say, for example, poor coding or testing practices. Sometimes we do, sometimes we ignore exceptional scenario or case in our program, or sometimes we do some hard coding values. So this is not a good practice, and we sometimes ignore the skip some test cases. So this is the one of the main reasons why we actually cause technical debt. For system design, most architects are focused on user features. We are very much concerned on user features, but in some of the cases, we forget about the qualities of the software, like maintain the performance of the maintainability, how easy to maintain a system, or adaptability if we deploy it in the new system. So if our components are very much tightly integrated, so we don't have breathing space to extend any new features. So this is one indication of a poor system design. For communication and collaboration, so it happens that internally the developers, they sometimes have poor communications among them. So daily stand-up meetings, for example, 15 minutes meeting, then members can synchronize each other and they can adjust and collaborate on their important tasks. It might happen that two developers, they have deployed the same features. For the lack of poor communications and collaboration. Lack of standard development process. So, for example, sometimes we don't follow the naming convention, or we do not documentize or code that actually make it harder for the maintenance, because it becomes difficult all the time. For requirements with no common definition of done, sometimes we incomplete or unclear requirement actually misinterpret the whole thing. For example, if we write done, what is done, if it is not defined well, developers may actually deliver the incomplete features. So it is very important to interpreting what is the requirement among the developing team. Lots of manual effort for release. Sometimes we need to put heavy manual work for deploying code. So, for example, if we put effort on database schema, so manual deploying, it is very challenging and risky, sensitive work, because database schema is very sensitive, because majority of the queries of the data, it is related with the database schema, even table name and the schema name. So this is very important. So when you put lots of manual effort, so you need to definitely try to reduce this approach. Lack of proactive investment in paying down debt. So sometimes we ignore the proactive task. For example, code refactoring or cleaning up, maybe database indexing, optimization. These things sometimes we ignore. Sometimes even we also ignore the vulnerabilities. So which makes difficult for the future fixation of any issues. Repayment plan. Repayment plan actually is an approach to reduce the technical debt, maybe by allocating resource. It could be human or any other resource. It could be time or effort to refactoring. So repayment plan actually it involves the prioritizing the debt items. We set the clear goals. So in the repayment plan, we need to explain the thing to the management. So if they understand, if we can compare with the financial debt, that financial debt is very much identical with the technical debt, and it has issues with the business in future. So definitely they will get motivated. They will engage to these maintenance activities. So it's also explain how it is impacting the responsiveness, the cost delivery. So this is this approach very much important to make them understand. Now we'll check the code smell and refactoring. Why do good developers write bad software? So since our requirement change over time, and it is difficult to update our code. So over the time, our code become suboptimal codes. So it could be one reason that the codes become loss its quality actually. Time and money cause you to take shortcuts since we have calendar deadlines. We have to do it, we have to speed it up, and money actually concerned with this thing. So sometimes we need to take the shortcuts, ignoring the ideal approach. So we learn a better way to do something. So first time in the experience that we have, we actually learn the thing. But the second time that we do, actually we try to do it better way. So these are the main things why do good developers still like bad softwares. So code smell, if we say smell means there are some flavors and that give us an intuition or anticipation that something wrong is coming. So code smell is a kind of indicator that something may be wrong with the code and can occur in both production and the development of the code and the testing of the code. Actually, the researchers, the Fuller, he actually he defined the code smelling and refactoring. So we will try to check this thing. So according to Fuller, the code smell has different indications. So alternative class with different interfaces. For the same functionality, for similar type functionalities, if we have different classes or different abstract class interfaces, so it gives us one signal that there might be some code smelling issues. For example, for the same action, maybe say human walk and bird fly. So these two are the same action for two species. This is action for the locomotion. So if it is the one action for the locomotion, so we do not give two different interfaces or classes. There might be many other examples. Say dog bark or say cat meow. So for this thing, we do not need different interfaces. Comments, if we give excessive comments, so it indicates that the developers, when he wrote it, he anticipated that this flow will not understand later when a developer will see it afterwards, and therefore he gave it lots of comments, maybe many irrelevant or unnecessary comments. So this could be one indication of code smell. Data class, sometimes we use data class. We just put the getter and setter thing. So it does not do anything more. So in those classes, we do not define any behavior of those classes, what it will do. So it is also one signal for the code smell. Data clumps means could be a group. So groups of data when frequently passed together. So it could be any problem. So for example, instead of giving the dimension of area, we could give the many parameters. So it could be one problem that later. So to understandably, we can just directly pass the object. Rather, we are giving the groups of data at the time. So, so divergent change could be a class might be changed for multiple reasons. So it could be one code smell signal. For example, I designed one class for enrollment. So in the enrollment class, if I modify maybe the registration or grading business logic, so it will definitely change the behavior of the class. So this is one indication of code smell. Feature envy is a method. Actually, the method uses the data of another class more than his own. So it could be one feature envy class. So if the thing is like that, what we can do, we can just move that class from where it is taking the data if I heavily relies on the other class. One is might be one is inappropriate intimacy. When a class actually have knowledge too much about other class, so this is kind of inappropriate intimacy. For example, in the employee class, have the knowledge of the payroll class. So definitely this is not ethical to learn about the payroll information. So this is one signal of code smelling. So our class sometimes might be very large, and it could have many responsibilities at the same time. Sometimes we have a class that is very short. It does not do that much work. So you can just follow this thing rather explaining by me all the things one by one. You can check it from any paper. I think you will learn this thing. There are some other code smell signals. Then we have the code refactoring. Refactoring actually modifies software to improve its readability, maintainability, and extensibility without changing what is its actual behavior. So external behavior definitely will remain same, but internal structure could be improved for the readability or maintainability. For example, if one developer departures from one project, still he can understand the flow of the code base. So that this is so, and that's why we refactored the software to understand, but the behavior definitely remains same. The goal of refactoring is not to add new functionality, the goal is to make the code easier to maintain in the future. Testing refactored modules. So refactoring can introduce problems. For example, during refactoring, one developer thinks that this part of the code is not necessary, it's not relevant. He might comment it, or he might remove it. Later, you can found that it might have the interdependency with the other module, the software. So and that's why the system might encounter some problems. So refactoring can introduce problems because anytime you modify software, you may introduce bugs. So management point of view, refactoring is definitely a risky task. It's expensive. We're spending time in development, but not seeing any external differences. Management will see this thing. If the management is not a developer, maybe in the earliest stage of its life, so they will say that refactoring will take a lot of time. Why are you doing refactoring? And if you experience any bug, so there might be some other financial issues. Refactoring might be the single most important technical factor in achieving agility. So this agility cannot be realized very immediately, but when we encounter or experience any experience any maintainability thing or extending feature, so it will show the necessity of the refactoring. So in the refactoring, duplication and needless complexity are removed from the code during each coding session, even when this requires modifying components and it is already completed. Automated unit tests are used to verify every change. Even after every change, we perform the regression testing. Another researchers, Beck, he defined that a change to the system that leaves its behavior unchanged, external behavior remain unchanged, but enhances in non-functional quality that is definitely understood by the developers, eventually the management later afterwards, when they get some benefit or they can avoid the technical debt by simplicity, flexibility, understandability, and the performance of the system. So Fuller's definition is change made to the internal structure of the software to make it easier to understand and cheaper to modify without changing its observable behavior. So composite definitions, changes made to the system do not change observable behavior. All the test actually still passes. Remove duplication or the needless complexity, enhance software quality, make the code simpler and easier to understand, make the code more flexible, and make the code easier to change. So composite in the terms of from the Beck or Fuller's or the other definitions, we can conclude that and these are the one definition of refactoring, though our system does not present any behavioral change, still the developers, the management find its enhance its quality or simpler and flexible and to understand. Why refactoring? Refactoring is, for example, prevent design decay. So in course of time, definitely system definitely will get decayed or reduce or loses its performance. So if we refactor it in course of time in the different stages of the software, we can prevent the system decay. We can clean up the messes, simplify the code, increase readability, understandability. So all these things definitely will become easier if we refactor our code. And when our code has a very simplified version of the code, definitely we can reduce our debugging time. So how to refactor? So refactoring, we need to make sure that before refactoring, we must need to make sure that our all the test passes. Okay, then we need to find some signals that we have found from the folders code smelling symptoms. We need to find some signals that we have. We need to refactor the course, and we need to determine where we need to refactor, how we will simplify this code. After planning, then we can make the simplification. Then we will again rerun the test that we have started in the first time, started in the first year. So if this pass, then we can claim that our system does not change its behavior externally. So we can repeat this simplify and test cycle until all the code smell signals just cleaned or it's just removed sideways. So this is one standard refactoring flow. So we can see that first we will check the actual system, whether it passed all the test cases. Then we'll find we will check the smell of the codes. Then we can locate where we need to simplify after doing simplification. So we'll repeatedly conduct the cycle until all the smell removes. So requirements for refactoring. So one could be collective code ownership. So all the developers can modify any part of the code base. They can improve the readability without any special permission, because all the relevant developers, they have the ownership of the code. Even in the they can check the coding standard, those who are in the team. Even sometimes peer programming style they follow. It helps that in the real time, if the other developer, the counterpart of the developer, if he makes any mistake, in the real time they can change it or make some comments. And so if we refactor the code, our code becomes very simple, and we can make some test. We can test the automatic test. continuously we integrate after changing to our main repository, and it will help to raise the programmer, because one rested programmer is very important to provide his maximum performance. Where to actually refactor? Anywhere that is provided test exists and currently pass for the code to be refactored. Someone else is not concurrently working in the same code, then we need to refactor. The customer agrees that the area is owed the time and money to refactor. If customer agrees, definitely refactor. When to refactor? All the time actually we need to refactor. When we add any functionality, when we learn something about the code, but it is not reflected in our code base, so we must need to refactor. When we fix a bug, we must need to refactor. When we get any smells that we might have some errors, we must need to refactor. When not to refactor? In the initially, if our test is not passing, then we should not refactor it. Sometimes we have our code has lots of errors and very faulty codes. So there is no benefit of refactoring it, rather we need to rewrite the whole code. When we have any deadlines, impending deadlines, so we should not refactor. Even we should not refactor it partially. Partially refactoring and the code actually it will make more inconsistent the whole code base. So code refactoring might have some problem. Actually, for every good thing, there might have some downside also. So people say that it takes so much time, still do not find any observable output. So it just take our time. It's just tinkering our time, waste of time and effort. Refactoring code when the tests do not work, or test when applicable does not work, leads to a potentially dangerous situation. So refactoring, if we have done refactor, but still our code do not work, so definitely we will be in dilemma. And database schema is very difficult to refactor because it is connected with so many queries. Okay, so it should have a very careful planning. So there are some interfaces, public interfaces or API, which is actually currently using by the some other stakeholders. So in those cases, it is also very risky to refactoring the things. So the management or the developers, they are kind of reluctant to refactor because lack of understanding, even we have lack of tendency of performing the preventive maintenance. We have short-term focus because we have what we have. I just will meet the immediate deadline. I do not need to think about the very long future. Not paid for, yeah, it is for refactoring. Maybe management will not agree to pay more. So since our program is operational, so we have a fear that if we refactor it, it might just might be broken, it might not work. So developers are very reluctant to these things.